Wasabi, you guys. We have a G-main looking integral here from MIT Integration B 2006. And what are we going to do here? We're going to complete the square-ish in a way by using 1 plus sine 2x trick. Let me show you what I mean. So, let me go ahead, go from 0 to pi of 4. Okay, so I notice, let me call this in yellow, our du, or our numerator, is in sine plus cosine form. Okay, so or let me just kind of switch this. So what this means is that if our numerator is sine x plus cosine x, or cosine x plus sine x, then I need a u sub where it should be sine minus cosine. Ah, gotcha. So what I need is I need 1 minus sine 2x. So what I'm going to do is I have 16 here. So I need, I need to turn this into a negative. Negative 16 sine 2x. Okay? So I need this to be negative 16 because we need our we need sine 2x to be negative. Okay, so in that case, I need 16. I probably should have kind of let me move this out of the way because I need well, this is not 1 minus sine 2x. The square version of this is 1 minus sine 2x. So I need 16. But then what I did is I technically added negative 16. So I have to add 16 again. Okay. So, and then plus 9. So what we have is from 0 to pi over 4. We have sine cosine, we have 25, and then we have minus 16 of 1 minus sine 2x. What is 1 minus sine 2x, you guys? It is s minus c squared. Okay, now be very careful. Now here's the tricky part that will eliminate a lot of people. Is it sine minus cosine, or is it cosine minus sine? This will determine whether you have a negative or a positive at the front of your integral. So you tell me, is it s minus c, c minus s, or it doesn't matter? What do you think? Well, pi over 4 is here. We're going from 0 to pi over 4. So any range here means that cosine is bigger than sine. So unfortunately, the truth is it needs to be cosine minus sine. So what that means is when we u substitute, 16 u squared. Okay, so technically we have to let u equal c minus s. Then we would have our negative du. Okay, then our bound. So now that our new u is c minus s. Okay, now when we plug in our bound, what is 0 when we plug it in? We have 0. So this would be 1. And plug in pi over 4, we get 0. Well, there you go. And this negative takes care of that. 25 minus 16 squared. Okay. And now this is just, let me divide everything by 16. 1 over 16 from 0 to 1 du of, this is technically 5/4 squared. Nice u squared. So what we have here is 4/5 inverse tangent of 4u over 5. Okay, this is going to be 20, so 1 over 20. And then from 1 to 0, so if we plug in 0, that's going to be 0. Inverse tangent of 0 is 0. So what we have our answer is going to be 1 over 20 inverse tanh of 4/5. You can honestly just kind of leave your answer like that. If this wasn't here, if we didn't have bounds, then you can go ahead and move on. Safest thing is this, it depends on the bounds. So whether it's s minus c, c minus s, it depends on the bounds. You just look at the unit circle. If it was here, like from pi over 4 to pi over 2, then we would leave it because sine is bigger than cosine at that interval. Okay? So be extremely careful. Be very, very careful.